Now, what about the exponential term? How do we deal with it? This. The exponential of I theta inside the exponential here can be expanded to cosine and sine I sine theta using the Euler formula. So we can now split up the exponential here, this and this, because there is a plus in the middle line is imaginary number, so I squared is negative 1. Negative 1, which means that this second exponential becomes the exponential of negative AR times sine theta. So again, we use this fact. Magnitude of the product of two complex numbers is the product of their magnitude. So we can now split up these two terms. The exponential of negative AR sine theta is a real number, and the magnitude of a simple real numbers just that real number. So we can erase the magnitude bars from here. Then we get this. That just leaves us with the first term here, which is the magnitude of a pure imaginary exponential, which is just 1. You can check it using Euler's formula, because you will get a cosine term plus I times sine term, and the magnitude of that will just be 1. Therefore, we can effectively eliminate this first term. So we get this. So now we can go back, cross out the exponential magnitude and perform the replacement on the integral here. As I said, less than or equal to integral magnitude of this d theta, and this will be replaced by this is capital R, and this is exponential of negative AR times sine theta, and then this. Here, the first term, magnitude of f r e exponential of I theta can be upper bounded by capital M sub r because of the assumption. You can check it, this. here m sub capital R is the upper bound of f given function f of I times exponential I theta as I just said, because this is the assumption for you can see that the magnitude of f of g is less than or equal to capital M sub R, but we just use the polar representation of complex numbers here, so g is replaced by R times exponential of I theta. So what we can do is that you can say that the function f is less than or equal to M sub R. So we yeah, a bar is omitted here. As we get the result just now, we can replace this using the relevant result here, and also we can use Jordan's inequality for this part. Then we get this. Because this is less than or equal to pi over capital R. But in this case, we use AR for variable R in the Jordan's inequality here. So pi over AR we get for our case. So pi over AR is replaced here. Then we cancel capital R. Then we get this result. Since as R tends to infinity, M sub R will be 0. So the theorem is completed.